Shut up! How'd the homework assignment go? Everybody got that working? Okay. So let's finish going through this example code. If you remember at the end of class last time, we, with the help of State Farm here, we saw what actually gets printed out. We put the nonce, a fake nonce in the front here, then the URL, and then a null was at the end of it, which is the empty string. We created a tool for doing a SHA-256 hash function, and this was the part that we were missing that he helped us with. So we had to initialize that with our whatever our secret key was, getting the bytes of it, and the algorithm we want to use. We then got our signature, which actually does the hash, and we printed it out. So I'll go ahead and run that, and we see a hashy looking thing. Okay, so this would be the value that gets passed in as our access signature. Okay, so the things that we're going to pass in to our when we open up our connection, we need to generate a nonce. So this is the millisecond since 1970. We need to generate our message, which is going to be that nonce followed by whatever the URL is that we're going to connect to, followed by this is an inline if statement. So for us, it's the empty string. Then we generated the signature. So that allowed us to, that's kind of the magic trick here, using SHA-256 to be able to communicate with the server. Remember, we're talking to CoinBase's system here, hopefully getting a balance. And I went ahead and I put my API key and my secret up here. All right, so I wrote the little note, start here for today. So now we're going to build our request to talk to the server. So we're going to build an HTTP request. HTTP is Hypertext Transport Protocol. It's the web language. So we're going to build a brand new variable called request of type HTTP request. Then we need to set a couple of variables. So in our case, since the body is null, we're not actually sending any information in the body of this request. Some requests to APIs might require you send it some JSON as part of the body. For this one, we're just requesting the balance. We don't have to give in any input as part of the body of the request. So for us right now, if the body is equal to null or the length of it is 0, so they've kind of given us two options. When we pass in the string here, we can pass in null for the string, which is nothing, or we could pass in the empty string. If either one of those things are true, we just set request equal to a new HTTP get. So this is going to be a get request. And we pass it the URL. Otherwise, we're going to create a post request with the URL, and then we'll set the body as a string entity for that. So this else is something we're not using on this particular connection. We're going to do a get request just to get the balance. All right. Then we're going to set some headers for that request. So we're going to set our access key, the access key. So headers are like things that, these are variables that we can set as part of the top level HTTP header. These are things we pass along with the request by default. They're almost always capitalized. So here's a variable name access key, which their API web server will look for. It's going to look for this guy, it'll look for the signature, and it'll look for the nonce. All right, so we're going to pass it a variable name access key, and the value we're going to give it is API key, which is this guy up here. Okay. Then we're going to pass it a variable name access signature, and the value is the signature that we computed right here, that we just looked at an example of inside of main a few minutes ago. Then we're going to set the header for a variable named nonce, access nonce, and we'll actually pass it the nonce that we created up above here. So here's where we created the nonce. We used the nonce inside of a message, which we then created a signature out of, but we still had it stored inside of nonce here. So that's just our random integer. So for access nonce, we're going to pass it the nonce. Now, if you remember, we look at how we created our message. Message was nonce plus URL plus, in this case, the empty body. Correct? Then we created our signature here. So if we're passing them our key, and we're passing them that signature, and we're passing them that nonce, are they able to validate this signature? Can they recreate that signature using the nonce that we sent them and the URL that we called? Put yourself on the recipient side. How did we build this signature? We built that signature using the message, this guy, which requires the nonce, which we're sending them. We're telling them what nonce we used, right? They already know what URL we called, because that's who they are. That's their phone number, okay? They'll also know about the body if there was one, because we would have sent that along with this request. That's plain text stuff. In this case, the body's the empty string, but in any case, they would know about it. So that's our message. Then we computed the signature. And what did we use to compute the signature? We used our secret key along with the knowledge that we're doing this with as a SHA-256 hash. Does CoinBase know about our secret key? They do. They know about our secret key. They can look up our secret key given our public key. Correct? Are we giving them our public key? Right there. We're giving them the public key. All right? So, if we give them the signature, and we give them the nonce, and we give them our public key, which they can then use to look up our private key, can they recreate this signature of validating that this message came from us, a validated user? Does that kind of make sense? This is how the authentication is working. So we're creating this signature on our end, which is a hash. And remember, a hash is a one-way cipher. Can't go backwards. So you're not going to be able to figure out the nonce or the secret key or any of that crap given the signature. But what they can do on the other side is they can take the nonce, they can take the URL, they can look up our secret key, they can compute their own signature and make sure those two match. And if they do, then they know, oh, this guy's a validated user. Make sense how the authentication works in this case? Okay, so that is an example of how public-private key secure authentication can work without ever having to pass a username and password. The only thing we passed here is our public key, which we can throw on a Facebook page, some number, a random number, and a hash value, which is just a bunch of gobbledygook that looks impressive. The signature really means nothing other than it's just kind of a stamp of approval. And then they're checking on the other end. Kind of make sense? So pretty secure authentication. This is an example of how a lot of the more secure authentications work today, as opposed to sending a username and password. So think about when you log into Amazon or you log into eBay, you're putting in your username and password. You usually check to make sure you got the little padlock. We don't even look anymore. We just assume, right? But when you hit submit, those two pieces of information are being sent out away from your computer over the network. So your password is being sent there. How secure is that? How does that security work? Would it be okay if it was a GET request, which we learned about in here? If our username and password was just up in the URL? So somebody standing behind you in the computer lab could just see your password? That wouldn't be cool, right? Same thing with credit card numbers. So maybe we do it as a post request. Is a post request necessarily secure? Or is the data just less obvious? It's not just sitting there staring at you, right? So somebody could, do a network sniffer or something like that. Look at all the packets that are being sent from a computer and pick apart those packets and find your password just hidden inside of a post request. So how does it work today? When you're in a web browser and you see the little padlock, what does that mean?
Ssl certified, right?
Okay, so it's going over. It's using an Ssl certificate for a secure HTTP server. So what it's doing is anything that's getting sent is getting encrypted. That's what the little padlock means. So your web browser knows how to take the garbage you're sending out, and instead of sending it in plain text, it encrypts it somehow, okay, using a security algorithm. It's not SHA-256. It won't be, well, it certainly isn't SHA-256 because it's not sending a hash. It's sending it is sending something that can be decrypted on the other end. So he mentioned something about an SSL certificate. So when you first go to a website, and that website is https:// that's a secure server. And the very first thing that we do is we download the SSL certificate. And that SSL certificate is basically a public key, which we can just put on our Facebook page. The web browser then uses that public key to encrypt all data that's being sent out. The web server uses their private key to decrypt that data to actually get your username and your password. Make sense? Okay, so that's not completely insecure, but the point is that the data that's being sent from your browser to Amazon server is in fact the real data that under the right circumstances can be decrypted to your username and password, because that's what they're doing on the other side, is they're decrypting that data. Where in this case, what we're sending them is either plain text crap that we don't care if they read, or something that is completely unusable in terms of containing data. And we're just asking them to recompute that on the other side. So pretty secure way of authentication without using usernames and passwords. All right, so we're going to set those three headers. Then we're going to use this HTTP client builder thing. This all came from org.apache. Remember the stuff we imported last time? All this crap down here that we included those libraries for. These guys. So we'll create our client builder. We're going to create a variable named response of type HTTP response. This is going to be whatever the server sends back to us, which is hopefully our balance in this case. So then we'll tell our HTTP client, this guy right here, to go ahead and execute. And what's it going to execute? It's going to execute the request. That's the dude we built right up here and started filling with all of our crap. That makes sense? So this stuff right here builds a request. This right here builds the ability to make a request. This line right here actually makes the request. So we use our client to execute the request we built. And what's going to fire out of there is an HTTP response. Whatever the web server, whatever that API gives us back. Hopefully in this case our balance. Okay. Then we're going to, from this response, we're going to request this thing called an entity. And as long as that entity is not null, as long as it actually contains something, you give us some real data, we'll go ahead and return the string version of that entity. Make sense? All right, so that's what this function right here does, this getHTTP function. It requires us to send it a URL, which is going to be our Coinbase API v1 account balance, as well as a body, which in our case is just going to be the empty string. So we're going to go ahead and test this. So we're going to print out whatever gets returned from this guy. Name of the method is getHTTP. It's a class method because it has static in front of it, so we'll call it with the name of the class in which the method was defined, which is inside driver. Driver.getHTTP. Here's the URL we're going to call this balance. And then what we'll be passing for the body, we can pass null, or we can also pass the empty string. Either one will work in our case. And we're going to print out that. Okay, we make sure we set the API key and the secret key up here so that our method down here can use those guys. We could have put them inside this method, but we might use them for other things. And we'll go ahead and run this. And there we go. The balance for that account is 0.00030,379 rich. It's a lot of Bitcoin, right? No, look, there's real numbers in there.
No, I'm talking about mine.
Real numbers in there. Now, if it was 0, you'd have just a bunch of zeros. But the point is that you got a real response here. Correct? So we just spoke securely to Coinbase's site, identifying ourselves as a real user, an actual user, and asked to give us the balance for that particular account. Make sense? And it sent it back to us in what we've described as simple JSON. And we have some methods for dealing with that, right? We wrote a JSON parser and a JSON var. What does our parser take? It takes some JSON string as a parameter. And then we have a display method. Now, right now, our display method is a little bit twisted because we're doing the var name contains US dollars and stuff like that. But what we're going to do here is, here, I'll just comment out that code real quick. That was all reliant on our knowledge of what we were getting for all those currency exchanges before. Let's just look at US dollars versus Bitcoin, and for your assignment, you're supposed to do euros to Bitcoin, right? So I'm just going to take every single thing in this loop, make ourselves a JSON var out of it, which is this dude. And JSON var keeps track of name-value pairs, and then we can display them. So we'll see that with no change, we can send that JSON string, what was returned, into our generic JSON parser. It's generic now. Before it was not so generic because we were hard coding it for what we knew it looked like. All right, so we'll go ahead and do that. So we'll say string JSON is equal to whatever gets returned. Whatever gets returned by our HTTP or getHTTP function method. Then we're going to say JSON parser JP is equal to a new JSON parser, and we'll go ahead and pass it our JSON string, because that's what that guy requires to, work. And then we'll go ahead and we'll tell our parser to display the contents of that guy, which should show us our individual pieces. Make sense? All right. Questions about any of that? Now, what I'm going to do is I'm going to give you this entire, actually, I'll just give you the whole thing. So I'm going to copy all this code. You will have to go out and you'll have to get the external library from Apache. And that's in last time's video, right? Last class's video. So what I want you to do is get this code working. Make sure you update the API key and the API secret to be the one for your account. You should all have 0 balances unless you went and did something like buy some Bitcoins, but no big deal. It will return a balance of 0 in Bitcoin. Okay? And get this code working for your particular API key. Make sense? So do that for Friday. So I'll go ahead and put that up on Angel now. That should take me to my 2:37, which is what I have to do to leave to get to my doctor's appointment. So I will see everybody on Friday, unless you have any questions. I do have 5 minutes. Okay, see everybody Friday.